So we've got that, and I'm going to share my screen here. Hopefully that'll work.
Okay. And I'll go ahead
Yay!
and do your introduction and then hand it over to you.
Okay, sounds great.
All right, everyone. With us this afternoon, we have Dr. Leanna Prater. Leanna is a solution engineer at LEGO Education. In this role, she helps provide content area expertise, thought leadership, and strategic solutions to support activities specific to the instructional goals and program needs of LEGO Education customers. Prior to joining LEGO Education, she taught in elementary grades and served as a district technology resource teacher for Fayette County Public Schools in Lexington, Kentucky. She occasionally serves as an adjunct professor teaching a graduate class on coding for teachers. She holds a bachelor's in elementary education, a master's in education and gifted education, and a doctorate of curriculum and in administration with a focus on instructional systems design from the University of Kentucky. As an advocate for STEM and computer science for all, she supports classroom teachers and students in areas such as robotics and creative computing. And in her spare time, she helps organize Scratch educator meetups in her area. If you have any questions, feel free to engage in the chat. At the end, we will invite participants to the screen. And if you have any problems, just let me know. I'm working on getting this fixed, the form fixed, and I'm going to step off screen, but I am here for support. Dr. Prater.
Thank you, Yolanda. I'm so excited to talk computer science and computational thinking using WeDo products today. I really enjoy talking computer science and sharing what I know with other people. So I usually put my slide deck in a presentation format, but for today, I'm just going to kind of run it like this. I think it'll make it a little easier to toggle between screens. And if everything's right with the world, I'll be able to switch my view here in a minute. So you won't see me anymore, but hopefully, if it works, I'll be able to share my document camera for some unplugged activities as well. So just a little bit about LEGO Education, if you're not familiar with who we are. LEGO Education is one branch of LEGO. Think about the whole LEGO group. So there's LEGO Retail that most people are familiar with. LEGO Education, we have a focus really on bringing educational solutions to classrooms. And then we have the LEGO Foundation. So it's always good to know that 25% of everything you purchase from LEGO actually goes into the foundation. And then that foundation turns around and does really great work. And they actually do a lot of research in areas like play and family engagement. So if you've never had a chance to check out the LEGO Foundation's website, I really encourage you to do so. They also have a really great booklet on there. Some of the activities we're going to do today are from that booklet called 6 Bricks. And it's free. You can download it, and it's things that you can do with just 6 2x4. We usually use Duplo bricks, but you could use 2x4 standard bricks as well for a lot of those activities. And in thinking a little bit about LEGO Education and our history, most people know us for Mindstorms. Mindstorms was one of the very first robots out there for kids with software designed for kids to create with. And I don't know how many of you know this, but the name Mindstorms actually came from Seymour Papert's book, same title, Mindstorm. So Seymour Papert actually worked with the LEGO company in designing that very first robot, and we still have a great relationship with MIT today. So most of you are familiar with Mitch Resnick and his lifelong kindergarten book. And also know him as the creator of Scratch. So we have a great relationship with Mitch Resnick as well. So for today's session, if you have a WeDo2 kit, that is awesome. You can get your kit out. We're going to be doing a very simple build with it today. And if you don't have a WeDo2 set, no worries, because you'll be able to participate some if you just download the software. So you can go to education.lego.com/downloads, and you can download the WeDo2 software if you'd like to participate in some hands-on learning today. That software is available for computers, for Chromebooks, for tablets and iPads. So I'll give you a minute to navigate and download that if you don't already have it. In addition to the software, if you don't have a WeDo2 set, something else that might be handy to have, if you just have some Lego bricks lying around, you might find those a little useful. Paper and pencil might be helpful for some of the activities for today. The first little activity we're going to do, probably just use some everyday items, whatever you have lying around, and bring your creative ideas, because we're going to talk computer science, but also talk through that lens of creativity and hands-on learning and playful learning. So I'm going to take a minute and see if we can switch my camera view real quick here.
Hopefully this works. We tested it the other day. There we go.
Yay. Okay, so I'm just going to leave it on my document camera for the remainder of the session to make life easier for everybody. So the WeDo core set, it has a lot of Lego pieces in it, but in terms of computing pieces, you have a hub, which is kind of like the little brain. We have a tilt sensor that you can program by how it moves. There's also a motor that comes in this set, and a motion sensor or distance sensor. It detects things moving towards it and away from it. Some people like to purchase a rechargeable battery, and you can do that. It doesn't come with the set. You can buy that separately. And if you don't have the rechargeable battery, no big deal. It runs off 2 AA batteries, and it lasts for a good long time. So for our first little activity, if you have some bricks, that is awesome. And if you don't have bricks, that is okay. You're just going to need six bricks. And if you don't even have everyday items around, that's okay too. You can use some paper and pencil to participate. So I have 6 bricks here that I'm just sticking out here. And so whatever materials you have, you just kind of gather 6 things together and we'll try to make it work. It's always fun to do hands-on learning in virtual spaces. So once you have your 6 items or your paper and pencil or your bricks, I'm going to give you 45 seconds to create a duck. So go ahead, take your items that you have, or if you're using paper and pencil, you can draw a duck, maybe with 6 shapes, and see what you can create. And as you're working, if you're not quite sure what to do, just start putting the items together, because you would be amazed at what your hands know. Your hands know a whole lot. And kind of winding down, probably have about 20 seconds left. Start just putting your final touches on. And I'll share my, please not too upside down. So I've built a duck there. It's kind of cool. We do this activity face to face, all of the different combinations and different ducks that are out there. So hopefully you created something that's pretty cool with your items. I like doing this activity because I think it makes people start to look at things a little differently. I did this once with everyday items I had laying around, with a stapler and some paper clips and probably an ink pen. And so I had to really think about the shape of those items and how it could work to make a duck. But believe it or not, this activity, even with just 6 bricks, you use a lot of brain power. How many skills do you think that you might use when putting together 6 bricks to form a duck? Any ideas? You can guess in the chat. Believe it or not, use 24 different skills, 24 different skills to build this duck. Spatial, absolutely. Abstraction, you know, you had to, when I said we were building a duck, you had to get the picture of the duck in your head. For one thing, when we do this with kids, we have 100% of the kids that build a duck. We usually don't have anybody that cries and throws their pieces down. So we have a little bit of self-regulation going on. But you wouldn't think that you would use those many skills, right? But you actually do. And there's a lot to be said about hands-on playful learning. Which is one of the reasons I personally fell in love with LEGO in the classroom, because it is this idea of play. And believe it or not, when you're playing, you have all these things that are going on at the same time. So when you're playing, you're usually happy. You're creating something that's meaningful to you. You're very engaged. You're often making things up as you go along, and it's highly interactive. You're very social. And the thing I love about using LEGO Education with computer science is sometimes I see these same things when kids are creating with code, right? When I'm in a Scratch environment with kids, they are so engaged that it seems like time stands still for them, and they're often making things up as they go along, and they're making those projects because they're meaningful to them, and they're having a good time doing it, and they're sharing in a community. So there's a lot to be said about creating and playing with code, just like creating and playing with bricks. So at LEGO Education, we are about this idea of learning through play with hands-on creative collaboration. And really, it's this idea of lifelong success, because we are building, trying to develop the builders of tomorrow and help everybody be successful. So the next little activity, also, if you have some bricks, that's great. If you don't, no problem. Just some paper and pencil will work. But I'm going to ask you this question. You can build your idea, you can draw it, or if you don't want to do either, you can just simply think about it. But when you think about computer science, what is it that you think about? How would you complete that phrase with your own ending? When I think about computer science, I think about what? And you can share in the chat if you'd like to complete the sentence with a word or a phrase. It's great because there's really no wrong answers, because it's just your ideas. Yeah. Lots of good ideas. Creation, logical thinking, absolutely. Problem solving, yeah. Learning from mistakes, and finding solutions. Yeah, there's a lot of problem solving. And there's a lot of opportunities to learn from those mistakes. I love that. So maybe when you think about computer science, you thought about some of these things. And when I did this slide, I think, oh, it goes completely against everything I know about good presentation design, because there's a lot of text on that slide, right? But a lot of this verbiage actually comes from the National Science Foundation's definition of computer science, with some extra things thrown in from the K-12 framework. So computer science is very broad, and we know that. But I wonder how often our kids, our really young kids, even understand how broad computer science as a field really is. I wonder if they think about jobs associated with that, and career pathways even when they get into middle and high school, at the elementary level. You know, they play a lot of video games, but I wonder if they ever make that connection between somebody in computer science is the person who might be designing those graphics, who might be designing the program for that game. And it really touches a lot of fields that we know. So I'm thinking about this rest of this presentation here. I love to toss out big questions. So how can we provide all children access to these opportunities to really develop computational thinking and those computer science skills and the knowledge and the dispositions to be prepared for life and work after graduation? Because we know introducing at middle school, while it's great, we really want to introduce these concepts early on at the elementary level so kids are prepared to take those courses at the middle and high school level. So one way we can do that, obviously, is through unplugged lessons, which I love for every grade level, because it allows for that exploration of computer science and computational thinking in hands-on ways, and it allows you to connect things to everyday life. I also enjoy it because it's easy to connect to other content areas, and it really helps develop those 21st century skills. And it gives kids an opportunity to practice academic language that they might normally not get the opportunity to play with and practice. So the next little activity we're going to do, I'm going to have you find, if you have a WeDo set, I want you to find these bricks in your set. So you should have a yellow 2x4, a black 2x2, the green 1x3 technique. It has little holes in it, and then a 1x2. And if you don't have Lego bricks, no worries. You can use paper pencil for this activity as well. Scooch everything down a little, make it a little easier to see there. And so the next little activity that we're going to do is actually a modified activity that I found in a book by Kiki Protzman and Jane, I think her name's Jane, called Computational Thinking for Every Student. So it's one of those books I really like. But it's an idea to think about computational thinking as a way to solve problems. So we're thinking about decomposing the problem or breaking it into smaller parts, generalizing or looking for those patterns, thinking algorithmically, then evaluating that, the process and kind of what we've done in debug, looking at our steps, and then the abstraction, so being able to conceptualize and explain those ideas. So this puzzle looks a lot like a Sudoku puzzle. And so if you have the bricks, you can draw on a piece of paper these grid lines and place your bricks where they need to go in the correct little squares there. And if you don't have a Lego set with you, you can do this with paper pencil, and you could probably just designate a color of a brick with a letter. But the first thing, if I wanted to develop a set of steps to solve this problem, I would need to decompose the problem. So I would need to think about what are those steps that I would need to put in order to solve this puzzle. So typically when you solve a puzzle like this, you begin to look at the bricks that are missing in row 1. And then you look at the bricks that are missing in column 1. And then you look at that bricks that are missing in quadrant 1, because the idea is that we want one of each brick in a row, one of each brick in a column, and one of each brick in a quadrant. And the bricks are not going to repeat. So if I look across this way to see what brick is missing, I know that the blue brick and the black brick are missing out of row 1. And if I look down column 1, I notice that the blue brick and the green brick are missing. And if I look in quadrant 1, I can see that the blue brick and the black brick are missing. And if there's only one brick missing from all 3 sets, then I know that that has to be the brick that goes right there. And if there's more than one, then I'm going to have to pick another row or column that has an empty square and start over again. So if I move to the second set of directions, so if I'm looking at bricks that are missing in row 2 and column 3, so it's this one right here. If I look and see what's missing here, if you notice, the directions are very, very similar. Do you see that? Because I'm looking at the bricks that are missing in row 2. I'm looking at the bricks that are missing in column 3. I'm looking at the bricks that are missing in quadrant 2. And if there's only one brick missing from all 3 sets, then that's the brick that goes there. And if not, I'm going to have to move and try another empty square. So I can look at my directions and begin to find some patterns. So you'll notice in the first set of directions, the very first step was look at the bricks that are missing in row 1. And in the second set of directions, the very first step is look at the bricks that are missing in row 2. And so because I have found this pattern, I can abstract and create one statement and then just fill in the number that I need for that row. So with that being said, you could do this activity with kids and you could have them create a set of directions, look for those patterns, create a set of directions that would include a common statement where they're just replacing the row, the column, the quadrant with a number, and then test it. Would those same set of directions work for a different puzzle in that same class? And then test it again. So you could have kids create their own puzzle patterns and exchange directions and see if it works. I loved this puzzle when I saw it because my daughter she actually just graduated with her master's in computer science engineering, and her whole master's project was around the same idea, much more complex level, but it was around this idea of developing an algorithm that would solve a particular puzzle within a class of puzzles, because she said that if she could create the algorithm to solve that, then it would solve any puzzle within that class of puzzles. But if she determined that the puzzle cannot be solved through a particular algorithm, then it would not solve any set of puzzles. So while this seems very simple, know that it is puzzles like this and algorithmic thinking that they're working on in graduate school for kids that are in computer science. But it's also a great way to really break down those steps of computational thinking that seem so abstract, to make it very relevant for kids. So the next little activity we're going to do is something called a back-to-back. And this activity, I'm going to lead, and normally how you do this is you sit back to back with a partner. And the only catch is partner A and partner B have to have the same set of bricks. And we usually use 6 bricks for this. This is a 6-brick activity that came right from the Foundation 6 Bricks booklet. So I'm going to put out here the bricks that I'm going to use. And these bricks that I'm selecting are all from the WeDo set. Oop. Now, if I could only figure out how to work the camera, it would be awesome. Okay, there we go. So I have 2 black 2x4s, 2 of the blue 2x4, 2x2 black, 2x4 blue, and 2x4 gold here that I'm going to use for this activity. If you don't have bricks, no big deal. You can just draw what you think this is going to look like when we're finished. But like I said, the only thing that's important is that partner A and partner B have the same set of bricks. So I'm going to use these bricks. So everybody look, 2 blue, 2 yellow, 2 black, and I'm going to build something, and I'm going to give you directions to build the exact same thing. So when you're doing this in person, one person builds a structure, and then they give directions to their partner to build the exact same thing. The catch being they can't see what the other person has built. And the goal is to build the exact same thing when they turn around. So, all right, so we're gonna do back to back. So if you have bricks, that's great. And if you don't, just draw a picture and I'm going to give you some directions. So the very first brick is a blue brick. And we're gonna lay that out in front of us. And then directly on top of that blue brick is a yellow brick, and I'm going to place it on top of the blue brick so that it is parallel and that there's no studs showing. So they're even on both sides, or actually on all sides. So the very next brick I'm going to put on top of that is one of the black 2x2s, and I'm putting it on the right side. So if I'm looking down, my brick has the 4 studs going across the bottom and the 2 studs going up and down. And then my black brick is on the right side of that, and it's covering exactly half of the yellow square, yellow brick underneath. And then I'm going to put the other black 2x2 brick right beside it. So it looks like I have one gigantic 2x4 brick. And when I'm looking at my bricks, they're in a stack directly on top of each other. So on top of the black bricks, I'm going to put a yellow 2x4 brick, again, parallel to the others with no studs hanging over. And then at the very top, I'm going to add that second 2x4 brick. So now I have a stack. All right, let's see how close you all were. So there's my stack. And the goal is that you've created the exact same thing, or maybe you drew a picture. So there's some fun ways that you can modify this activity for kids. For kids that need to look face to face, you can have them block the build with a book. Very close, Brian. Oh, that makes me happy. You can have kids do a mystery build where they build it and then they write out the directions step by step on how to build it, and then give the directions to somebody else to try to build. That is actually kind of a good way, if you're in a virtual setting, a way to do this virtually. You could also do like I did, where you're leading as a teacher in a virtual setting and have students try to build exactly what you're building as well. Or you can have one of the students do it with the rest of the class in a virtual setting. That works too. Some other ways that you can do back-to-back. If you're doing it with younger students, you can start out with really simple builds. Instead of 6 bricks, maybe 3. We usually use Duplo because they're larger and it makes it a little easier to handle. And you're really focusing on that step by step. First this, then this, next this. And you can practice using some terminology. You could even introduce it as writing an algorithm to create your build. For older students, again, I always start out with simple and get more complex as you go along. You can use standard bricks. One idea is you can have kids build something that's a little more complex, but they have to assemble part 1 and then include that small build as part of a larger build in their builds. Or maybe they could write the directions in a different way to create the exact same thing. And then you can begin to introduce even this idea of pseudocode to them. And so you're kind of hitting on lots of different computer science concepts with this, but for this, through this lens, I'm really thinking about algorithmic thinking. So thinking along those lines, right? This idea of algorithmic thinking, this idea of putting things in order and sequencing. We're going to move over to the WeDo kit itself and build something really quick. So if you have the set, I'd really like for everyone to build the cooling fan. And the cooling fan's pretty simple to assemble. It takes all of about maybe 5 minutes. I think it takes longer sometimes to find the pieces than it does to actually construct it. But you're going to use the 2x4 blue and then one of the 2x4 yellow to make a stack. That just sits on top of the hub. And then this piece is just 2 of the, put it here, 2 of the green plates with this piece that's in there. It's like an axle on one end and a connector peg on the other. So the axle just fits into the motor. And then you can stick your little fan on here, blades, and then that just sticks on top. And if you've never used WeDo before, it's pretty easy to just plug in the motor or the sensor to the back. You just plug that in. Pretty simple. Now, if you don't have a WeDo set, no worries. I'm going to have you launch the software because you can participate creating a sequence of programming using the music block. So the music will actually play in the program, regardless of whether you have a WeDo hub connected to it. So I'm going to pull up my software real quick here. And if you're on the splash page, you can click on create a new project, and then, or if you're looking down at the bottom, sometimes you have what looks like a little book. See if I can pull up it on my iPad here and show you. If you're on an iPad or a tablet or a Chromebook, it'll look like this when you launch it. And then you just click on the plus sign to start a new program. So if you have the WeDo, I'm going to have you write a program that is going to turn your fan on. So the first thing we need to do, though, is connect with Bluetooth. So if you look on the hub, you'll see a little green button. So I'm going to press on that. And then in your software, you have this picture of a hub, and the hub should show up. So mine is called Mini. And it'll just take a second for it to connect there, but well, might help if I get it going again. So you'll know you're connected because your hub light will turn a solid blue. So you'll know you're good to go. And it'll show up over here that you're connected. Mine's probably just taking a minute. It has to really want to connect. So to write your program down here at the bottom, you'll notice you have a motor block. And so all you need to do is just snap that little motor block right beside this green play button and then hit go. And then your fan will turn. Now it's going to go on forever because I didn't tell it to stop and I didn't tell it for how long to stay on. So to make it stop, I'm just going to hit this little red square over here. Now, if you don't have a WeDo set, you can come down here and pick this music block and change the number. There's lots of different things here that you can pick from. So you just pick a number and then hit play. And you probably can't hear it because it's going through my audio, but it will play a sound for you. 3 was actually crickets. So I want you to take a minute and just see if you can get your WeDo fan to turn on, or see if you can get some music to play or sound to play. And you can change that number to something else. And if you want to change how fast your fan is going, you can change 8 to a 4 or to a 3. 43 will not do anything. Kids will tell you that it's going really fast, but between you and me, the fastest you can make that little motor go is 10. Unless you do a little activity on gearing, and you could challenge kids to figure out if there's a way they can make something spin faster using gearing, but leaving the power level of the motor the same. That's always a good challenge too. So in thinking again about this idea of sequence, see if you can add some more blocks to that line of code. So if you're using your WeDo and you've got your fan built and you've got the motor turning, see if you can add a sound, see if you can, yeah, it's so exciting when it spins. See if you could turn the hub light on or off, see if you could display an image. And if you're just using the WeDo2 software, you can see if you can display an image or maybe even begin with a countdown. So if you want to play around with an image, we have this little thing that looks like a picture here. And I can pick things from down here. And so when I hit go, it's going to display a picture. Now, if you want to get rid of the picture, you just click on that little X and it goes away. And I can hit stop and it will stop. If I'm running my motor of my hub, I can play around with the timer. So I can turn it on for a second and then maybe change the hub color to something else. And then maybe I'm going to leave that on for a second and then maybe change to something else. So we're really just putting these programming blocks in order. And it's just running from beginning to end. So it's really a great way to introduce the idea of a sequence to kids. And because you can program in the software without having the hub, if you needed to in a virtual classroom, or while kids aren't there, they can actually play around a little bit with music and the image display, just tinkering around with the concept of sequence and seeing what they can do with that. So we're going to move on and thinking about another unplugged activity. So this is one that you've probably seen before. I'm going to move my fan for a minute. But it's this idea of assigning an action to a brick. So here's something I could do really easy. So I have, I'll put them this way, blue, yellow, and a black one here. And maybe my actions are going to be stomp your feet. And this one might be wave your hand. And this one might be clap. And so as a teacher, you could also use this to talk about events if you wanted to have a big event block here to launch your program, right? But if I pointed to them, you know, in order, stomp your feet, wave your hand, clap, so kids kind of understand that there's actions associated to this, then we could have some fun with creating our own dance almost, or set of actions. We could put some music to it in the classroom, or have kids create their own using some bricks and assigning actions to it, and then testing it out with other kids. But then you can introduce this idea of looping. I had a little flat plate here, but I think I'm going to use this little blue one because I think it'll be easier to see. Actually, I'm just going to stick it on top of this so you can see it. So let's say I wanted to put this white plate at the end. And now I'm going to say, well, if you have a white plate at the end, we're going to repeat this whole series, however many studs I have here, right? So we're going to repeat our actions twice. Or maybe I could stick it here. So we'd repeat this twice and then do the rest, right? And I could have something else down here. So you could introduce this idea of looping with just an unplugged activity with some bricks that students have available to them in their classroom. And like I said, I'm using the WeDo bricks for this. You can use whatever you have available to you in your classroom. Sometimes people just get lots of bricks donated to them from parents. And I love sharing ways that you can just use bricks in the classroom if you have them available. So again, you can do this with young kids with Duplo, starting out with like 3 moves, getting them to start thinking in that language, right? When I see this, I'm going to do this, introducing that idea of looping with them. With the older kids, standard bricks, starting with a few moves, but then moving to more complex ideas, including looping and then nested loops as well. So in we do have a looping feature available, and you'll see it's this yellow brick right here, our block that you can pull up. It looks a lot of kids think that our WeDo blocks actually look a lot like Scratch Junior, if you're familiar with it. So kids will be like, oh, that looks like the Scratch Junior block. And they do have a lot of similarities to them. So I can come down here and grab this little loop. And now I can stick things in here. So like maybe I want to stick this music block in there, but I want it to wait a minute or a second, actually. I want it to wait a second before it continues to repeat. So I can turn that on like this and put it in there. I could also create a loop with my motor block and take these apart here. Maybe turn my motor on for 1 second and then continuously repeat. Maybe I'm going to put my little light on here too. So now when I run that, it's just going to loop. It's going to turn, it's going to switch the light color. Actually, it won't switch the light color because I never switched it back. So that's a great little debug activity because it'll be like, oh, the light color is not changing. Well, that's because we never told it to change to a different color. So it changed and then it's just stayed that way. So if we wanted it to change to a different color, we would have to tell it by adding that block in there. So right now it's on a continuous loop because we haven't just hold it to stop. But you can add a number down here if we wanted to, and just plop that there. So now I can loop it 3 times or 4 times or 10 times or however many times I want it to loop. You can also have the loop interrupt with something else, like a display as well, which is kind of cool. So take a minute and see if you can create a program with a loop using that loop block there. Lots of fun. And if you don't have the WeDo set and you're just using the software, see if you can play a sound, make it wait for 1 second, play another sound, wait for a second, and then see if you can get it to repeat 3 times. If you're using the fan, see if you can add a sound and then wait a second, or you could use the light and change the light and see if you can get it to repeat. Hopefully you're having a good time in there. So another brick you can play around with while you're playing around with looping is this idea of a variable. You'll notice that when we have those bricks that we're sticking under the timer, when we're sticking under the motor, that those are numbers that can change. But there's also this little brick right here that looks like a dice. Fun sticking under something. I'll pull it up here. So let's say I take out my 4 for the light and I replace it with this dice. What do you think is going to happen? Any ideas? Yeah, random, absolutely. So when we have a random number for a light, we don't know what color it's going to be. If you pick a random number for the motor, it might go very fast, it might go very slow. We don't know. Same thing with random for looping. When we run it, we don't know how long it's going to run for, but it is kind of fun to play around with. So if you stick that random block in for light, it will change the light color most often every time it goes through. Not too often will you get it randomly picking the same number as it goes through. If you are using just the software, it's kind of fun. You can randomly select a song to play. So it'll randomly just pick one of those numbers that are down there, one of those songs that are associated with that. And just to let you know, if you're curious, you'll notice we have a microphone down here. You can actually record your voice. So if you're working with really young kids and you just want to get them kind of acclimated to maybe WeDo software before you introduce the set to them, you can do some fun things by just having them record their voice, maybe add a sound effect to a story that they've created in the physical world, just to play around with those blocks and get familiar with the concepts. It's a lot of fun. But the sound block that you can, the record block is a lot of fun. People have a good time with that. So we also have this idea of conditional. So like waiting for something to happen. So this is where you can add a sensor in. So right here, this set of blocks here, we have waiting for this tilt sensor to be tilted in a particular direction before the program is going to run. You can also play around with the microphone if you don't have the WeDo set, and you can have this conditional right here where it says wait for sound. And I'll tell you, I was playing around with this yesterday. You have to be pretty loud to get it to go, but it will launch with the microphone input. So see if you can create a program where you're using the conditional. So if you're adding a, I'll have to pull this one out of here. Have 2 hubs sitting here. If you're adding the tilt sensor, you're just going to plug it into the second port back here. And then you can kind of play around with it to see what happens when you make that your conditional. Or if you want, you can play around with the other sensor. I'll show you where that block is. So down here at the bottom, here's the one for, so if we wanted to wait for the tilt sensor, I'm just going to drop that little block under there, and then I can have it wait for it's tilted towards the right there. Or if I wanted to, I could try the distance sensor. And if you click on the brick, you'll notice that the images change. So that means something's getting closer to it, moving further away from it, any direction, or none at all. And the same thing with this one. When you click on it, you'll notice it changes. And if you're ever curious about what all these bricks mean, in the help section, if you click on help, you can pull up the teacher's guide and it'll tell you what all the bricks do, which is really helpful. So take a minute, see if you can create a little conditional statement there so that your program launches after it has, after the tilt sensor is moved, or after you have, let me find it down here, made a very loud noise, which is fun. Move all those bricks out of the way. For everybody out there that's having an opportunity to play, you having plenty of time to program and test. Want to make sure. It's hard when I can't see people. Hopefully you're having some fun. So the last thing in WeDo, the software I'm going to talk about, is this idea of events, but using the messaging blocks. In Scratch, it's called broadcast. In LEGO, it's called the messaging blocks, but the concept is still the same. And it's this idea of sending a message at the end of a series or a sequence of blocks that will launch another sequence, right? It's the event that's going to launch another set of code to run. So here I have, wait for sound. And then when I hear the sound, I want to turn the motor on to power level 4 for 1 second. I want to repeat that 3 times. And then I'm going to send a message that says picture. So down here, I have when I receive picture, I'm going to show the picture. So at the end, it's going to launch this right here. So over here is a set of code that if you're just using the program and you don't have the WeDo set, you could test it with this, with the sound block and a message that will also display the picture. I'll show you what it looks like in here. So here are the blocks I'm talking about. Looks like the little envelope. So this block is the block that you would put on the end of a code to send the message. And you'll notice it just says ABC. So you can click on that and you could type whatever message you want. I'm just going to put M1 for message 1. And then up here for my event block, I'm going to put M1 because that's what the computer is going to listen for to know to run this set of code. So maybe I'm going to turn the motor on. We turn it this direction here, and we turn it the opposite direction here. So you can kind of play around with it a little bit. Maybe display a picture, all kinds of things. But it's this idea of the computer being able to launch something else based on a message it receives. So it's this really exploring this idea of events and how you can use them in complex code. And I'll show you really where that comes into play here in a minute. For those of you who have used WeDo in the past, have you played around with the messaging blocks before? If you have, you can just say, yep, in the text area, or if not, you can say, nope, had no idea what those were, which is okay. Yeah, I didn't, when I first started using WeDo in the classroom, I hadn't gotten to this idea of messaging. I saw it there, but I really, to be honest, I really didn't quite understand what it did. So I had to take some time to play. And then once I figured it out, I thought, man, that's really cool on how that works. So just some other things that you can do with the WeDo set that maybe you didn't know about. So did you know that you could connect multiple hubs to with the WeDo set? Anybody out there? Did you know that? So when you connect multiple hubs, and sometimes people will accidentally click on a brick in a certain place, one of those programming blocks up there, and they'll get that little grid that pops up. And I get a lot of questions about that. They're like, what does that mean? Well, that grid is used when you have more than one hub connected to one piece of software. So you can actually connect up to 3. And you'll notice when you have one hub connected, you have I have the motor on over here in my software because that's what's plugged into it. And there's nothing here because I don't have a sensor or a motor plugged in to the other port of that hub. But when I go to connect a second hub, you'll notice I get additional information down there. So here's my second hub. Both lights are blue, so I'm connected with both of them. Have some pretty complex code here, so we're going to move all this around. Take that down for a minute to start fresh. So over here, you'll see I have 2 hubs that are connected. By the way, something else, just a helpful hint, you'll also notice in this Smart Hub menu a little pencil, and you can click on that pencil to change the name of the hub. So if you're getting brand new WeDo sets, you've never had them before and you have a brand new one, I highly recommend you change the name because the name of the hub is the same default for every new hub. So when you have kids trying to connect, they'll all have the same name up there, which is a good time. But now you'll notice down here where I have 2 hubs connected, I have my motor plugged in, but now this is my second hub and I have a tilt sensor plugged in right here. So let's say I want to write a program so that when I tilt the tilt sensor to the right, the motor of my other hub will turn on. So it's almost like I want to create a controller for this fan using my other hub. So the first program I'm going to write is for my tilt sensor because the tilt sensor action is what's going to launch the fan turning on. So I have to do my little wait for. So we're going to wait for the tilt sensor to turn to the right. And then I'm going to send a message. I'm just going to say fan. Now you'll see where this messaging comes in a little handy here. And when I turn the fan on, or when it receives fan, I want the fan to turn on. So, 1 second. I'll turn him on for, we'll leave him on for 1 second. Now, if I run this program the way it's written, if I launch the program and turn my tilt sensor to the right, the fan will come on, but if I turn it to the right again, will the fan come on again? So the question is, will the fan turn on once or will the fan turn on every time when I move the tilt sensor? What do you think? Any ideas? You can chat me up in the chat box over there. Yeah, probably just once because of the way that it's written. But let's test it out. We'll see. It's always fun to test your code, isn't it? Yep, just once. So what block do you think I would need to include so that every time that I turn this to the right, the tilt sensor to the right, that the fan would turn on? Yep, a loop. And where do you think the loop should go? Do you think the loop should be around the blocks with the tilt sensor, or do you think the loop should be around the block with the motor? Yeah, the tilt sensor. So I'm going to come over here, find a loop, and stick that right around there. Pull this up there a little bit so you can see. Have that for 1. He seemed to be on there for a long time, but we'll go here. He's really thinking. So we've launched the program. So every time I'm turning the tilt sensor, it's moving. Now, what's really cool is if I had a third hub connected, I could actually control the third hub if I wanted to by writing a similar program where the tilt sensor is going in the opposite direction to control a third hub. So you can provide some pretty complex computer science activities for your kids with the WeDo software just by changing up the hardware, right? So if you have kids that are they're ready for a little something more, maybe something a little more challenging, or maybe you have 2 groups of kids that are working together, you could challenge them to create something that would interact with each other, right? 1 program for 2 hubs or 1 program for 3 hubs, which is a lot of fun to do. And like I said, you can tell down here. So, I should show you here. So this is where you assign the hub. So let's say it's working pretty good for me. We're here for this one. So you'll notice here that when I press this little corner, the right corner, I get the hub. So it knows that the motor's attached to this. If I had 2 tilt sensors, by the way, plugged in, this wouldn't necessarily know what tilt sensor I'm referring to. Let me pull it out of here for a minute. So you'll notice when I press and hold on the right corner, the little grid pops up. But now I can click this and change it so that the color of the square, this is green right here, corresponds with the color right here. So this is green. This little red dot right here corresponds with this little red dot right here. So I highly recommend that kids go ahead and kind of pair the block with the hub and the port so that they don't run into any hiccups for that. Lots of fun. So you might be wondering what else you can do with a WeDo set, because there's a lot you can do with a WeDo set. So one of the other things, if you didn't know, you can actually change up the programming language for kids. So maybe they've been in this block-based interface a while and they're ready to move into blocks of text language, right? So you can actually program our WeDo set with Scratch 3. And you have to turn on the extension. So I'll show you where that is real quick here. Here's my Scratch software here. So I'm just at scratch.mit.edu and I'm actually logged in. So you'll see me here. So we'll give that a minute to pop up. But if you've never been in Scratch before, if you scroll down to the very bottom, you have a block that looks like a little flag icon. It might have a hard time loading because I'm stressing out, I think, my network connectivity at my house here. We'll just minimize that and hope that comes up here, but I'll kind of walk you through it. But you'll have a the little flag icon at the bottom. If you click on it, you can see all of the extensions that you can run in Scratch 3. And the really cool thing is you can run all of those extensions simultaneously. So you can combine your WeDo set with video sensing, or you can combine it with text to speech, or you combine it with the pen or music, or even an EV3, because we have an EV3 Mindstorms extension in there. So anything that you see in those extensions, you can launch it and run them simultaneously and allow your physical computing things to work with each other in that software, which is a lot of fun. When you're in the extension, they have a little button that says help. This is what the extension block looks like, by the way. They have a little thing in the corner that's for help, and it'll take you to a starter project page, and it'll also take you to a site where you can download something called Scratch Link. So you need to have the Scratch Link installed. Have some tips for Scratch Link. Good, I put those in there. I wanted to make sure. You need to have Scratch Link installed and running in order to allow your physical computing devices to talk to Scratch. So you need that Scratch Link for the WeDo, you need it for EV3 and any other physical hardware that you see listed in the extensions. But also on that page, you'll see some starter projects. So there's Make Your Own Pet, which uses the motor. There's Move the Fox, which uses the tilt sensor. And then there's the inflating puffer fish that uses the distance sensor. So it's really fun to be able to combine our WeDo set, even with consumable materials. I love combining WeDo with construction paper and tape and all of those other fun things that kids love to have available to be artistic in addition to bricks. And they can create some really fun projects combining Scratch with WeDo and some consumable materials. I will give you some hints on using Scratch Link, by the way. You need to make sure that it's installed and running. I usually launch it before I even open the Scratch software. You need to make sure you're connected to the internet, and you need to make sure Bluetooth is turned on your machine. If you're using Scratch with WeDo with a bunch of kids in the classroom, it's really helpful to stagger pairing because the name of the hub won't show up in Scratch Link. So if you just have kids connect one at a time, you can make sure that they connect to their correct device. And then sometimes you might just need to reconnect, and there's a little orange button that you'll see in the top when you have the WeDo blocks open. You'll see a little orange dot. I think he's still loading there. Let's see. Oh, there he goes. So if I launch Scratch extension, so you'll see all of these. You can run all of these at the same time, which is kind of fun. So I don't have Scratch Link turned on, but you would start searching here. Just like when you connect with WeDo software, you press the little button. It'll start flashing, and the WeDo will show up here, and you just click on it up here, and it'll connect for you. Here's the help button that will take you to the starter projects and where to download the Scratch Link. But you'll notice once you've launched the extension, you now have a set of Scratch blocks over here. If you've lost your connection to Scratch Link, you get this little orange kind of caution sign, and you can click on that and reconnect if you need to. But now you have the functionality of all of these Scratch blocks with your WeDo. So it just kind of takes it to a completely different level on what you can do with that. I have I have started a studio. You'll see all of my crazy projects here. Where I've started compiling some Lego and Scratch projects, either things I've personally created or things that I have just found out in the Scratch community. So like the catch ball game actually combines WeDo tilt sensor. So you're moving the tilt sensor back and forth to catch basketballs. And when the score gets so high, it actually turns on the motors of an EV3 robot so you can kind of race, which is fun. But there's lots of fun little projects that people have created. This particular one is a hot potato game that I made, and it just uses the hub and nothing else. So the hub is your hot potato, and the lights change, and there's music that plays. So it's just like the hot potato game. And that was a project that I challenged myself to create to see if I could make a Scratch project that could be played with a large group and only use minimal pieces from the WeDo set. A lot of times I'm on the road, and I thought, man, if I'm going to go do a presentation or share something with somebody, I'd love to be able to carry the hub with me, but what can I create with that? And so we have the hot potato game, which is a lot of fun with that. And if you're thinking about even kind of how they relate, like our programming blocks to the Scratch blocks, one thing I love to have kids do when we move from WeDo to a Scratch interface is just have them program it in the WeDo software. So right there I have my, when I turn the when I click the green button, turn the motor on for 2 seconds. And then think about that, thinking about pseudocode, right? Really, what are these blocks telling me to do? And then if I can say out loud what these blocks are telling me to do or what I want them to do, I can find those blocks in Scratch to do the same thing. So here's the code over here in Scratch. So why do I love LEGO Education stuff? Well, really because it provides a low floor, high ceiling, wide wall approach to integrating computer science. Getting started is really easy. For those of you who built the fan, you'll notice building that fan didn't take very long at all. Even if you don't have the software, you can get around, tinker around with the software. It's block-based. So for kids and for teachers who've never programmed anything ever, it's not a heavy lift to get going, right? And I'll show you some lessons here in a minute that are also embedded in the software. But it definitely has this high ceiling. Because we can connect multiple hubs, because we can use it with other programming languages, the ceiling's pretty high in regards to what kids can do. And I like to think of it as wide walls in a couple different ways. One, it supports lots of different learning styles, and kids coming from lots of different backgrounds, they can connect and create with WeDo software, but it also fits into lots of different content areas as well. So it's very flexible in nature. And I'm going to pull up my program one more time here. If you notice, it does have lessons that are built in. So if you're not familiar with WeDo, I wanted to make sure I shared this with you. So you have these 8 getting started lessons, and they're just to get started. They acclimate the teacher and the kids to software and to building. A lot of kids have never built with Lego bricks before. A lot of teachers have never built with Lego bricks before. So the builds are pretty easy to get going, and the programming blocks are there as a scaffold to help you get started. And then you have full-blown guided projects. So it's a guided lesson. It walks you step by step through the entire lesson, starting with big questions, having kids build to investigate that question, and they're programming that build. And sometimes they're collecting data, or they're just making observations, or they're creating an iteration of a design, whether that's program design or the build design or both, to help answer that question. And sometimes they have their own ideas when they're working through these, and they always say, I wonder what would happen if I did this. And it gives them that flexibility to kind of go down that path a little bit. But it promotes sharing, because we always suggest that, that kids have the opportunity when they can collaborate, when we're not under social distancing rules, right? That they can collaborate with each other on projects. And it gives them the opportunity to use that language, like I mentioned earlier, and sharing out what they've learned. And then we have just some open projects. So if you've downloaded the software and you don't have the WeDo set, I'm just telling you, these open projects are great, just PBL lessons. Like, they have great questions that kids can investigate and create something for. So there's, predator and prey, where they're designing a predator or a prey. Sometimes it's fun to assign a predator and prey that you know are related to 2 different kids, and have them build and create and program that predator and prey relationship. But down on, scrolling on down here, we have guided projects for computational thinking, which really, again, goes back to those early concepts I shared at the beginning of the presentation for computational thinking, right? It's to practice that process. So we have guided projects for computational thinking and open projects as well for computational thinking. So I just wanted you to know that those are available. All of our lessons and our software are free. So you can download the lessons, you can download the software on any device that it's compatible with. And our lessons are available on our LEGO Education Lessons webpage, in addition to being embedded within the WeDo software. So one last quick little activity I'm going to show you with Lego bricks before we wrap it up. So I've been talking a lot about the algorithms and programming area of computer science, which it's easy to talk about when you're using WeDo and WeDo software in Scratch. But I want to show you too that you can hit some other areas with some unplugged stuff. So one, I call this Guess My Brick. So you can introduce the concept of complex passwords to kids. So I have 3 brick colors here. And we're going to see how good you are at guessing my password. So I'm going to tell you that my password is going to be 1 brick color long. And these are the 3 brick colors I have. So it's going to be yellow, blue, or black. Now, I'm not going to tell you what my password is, but I want to see if you can guess. Okay, so see if you can guess what my password is. It's either going to be yellow, blue, or black. And guess in the chat real quick. Oh, some good guesses. Yeah, so my password color is blue, right? That was pretty easy to guess. And if I were doing this with kids, I would have them keep tally. How many times did your partner guess before they got it correct? Because if we're using only bricks with 3 colors, they should guess within 3 tries, right? So if I were protecting something of great value, that would not have been a very strong password. So you can kind of change up this activity with kids by saying, okay, well now instead of 3 blocks, maybe I have 4, you know, or maybe my password's going to be 2 bricks long and you have to guess them in order. Brick 1, brick 2. Was that harder to guess? Or maybe instead of just the brick color, now you have to guess the color and number of studs for each. Is that harder to guess? So you can talk about how you can make a password more complex and why it's important, because it is harder to guess. And when you start moving beyond just color and you're thinking like number of studs or shape of the block or whatever, you can relate that back to even letters, capital letters, lowercase letters, numbers, symbols, like why we have all of those things within our passwords. And so there's some ideas around that as well. And just real quick, I just wanted you to know WeDo is part of a continuum for computer science. And there was share out, but I'm at time, so I'm just gonna give you some information there. There's all of our social media handles. I'm at Total Teacher. I do try to tweet occasionally, but LEGO Education's on tweeting a whole lot. They're on Instagram and Facebook, and they love to see what people are doing out in the classroom. So do we have any questions, Yolanda?
Someone wants to know if we'll get access to the slideshow. And if you didn't know that the video will be available on YouTube, but we will see about getting that slideshow from you. I'm talking kind of fast because it may cut off in just a minute. Okay. There's some end of the day announcements coming to the stage, but Dr. Prater, I want to say thank you. This was awesome. Brian is going to jump in real quick.
Okay.
Hopefully.
Yeah, I'm more than happy to share a PDF of the slide deck to you all if you want to share it out. I'm more than happy to do that.
We can do that. Brian, you're on.
Oh, I actually pressed the button on mistake, but thank you so much, Leanna. That was fantastic. I appreciate it. I wish I could show you my my set here that I've been working on.
Oh, cool.
And now that I know that I have some other apps and activities that I can explore, I'm definitely going to use the Movie Maker. Somebody mentioned that in the chat, that
Yes.
WeDo works well with the Movie Maker. And I'm going to see if I can find a way to get my hands on another hub. So
I
Awesome.
didn't know where you could get that, Brian, since you know some people.
Ooh, see, all you gotta do is say it out in the universe is going to hear you. So,
all right, I don't want us to get cut off. Thank you so much, Dr. Prater. This was awesome.
Yes. Thank you all so much. I hope you had a good time.
All right, join us on the stage.